All right, here we're going to have a lesson on special right triangles. I like to think of special right triangles as kind of a shortcut to the Pythagorean theorem. We only use it for two types of triangles. They're both right triangles, and one case is when it's a 45-45, 90, and the other case is when it's a 30-60, 90. And what we know is that these particular triangles have certain relationships that will always be the same, so we can kind of take some shortcuts when we do these. So let's take a look. On a 45-45, 90, since both angles, these base angles are both 45 degrees, that makes this isosceles. So we know these two legs are always going to be equal to each other. And then if you'll notice here, the hypotenuse is just the leg times the square root of 2. So that's going to be the case no matter what when we have a 45-45, 90 triangle. So here in this picture, I can say, well, if this is 4, this must be also 4. And if this is 4, this must be 4 square roots 2. Looking at my little chart over here, x and x, the hypotenuse is the leg times square root of 2. If I did this with Pythagorean theorem, I would say 4 squared plus 4 squared equals y squared. Then I would say 16 plus 16 equals y squared. Then I would say 32 equals y squared. And then I would take the square root of both sides. And then I would say, well, that's not a, that's a decimal, so I need to factor this and find perfect squares. 16 is a perfect square, so it becomes 4 square root 2 equals y. So you can see this is Pythagorean theorem, and knowing this relationship, you don't have to calculate anything. You just know that's what it's going to always be, that relationship. All right, here's one. If we have a leg of 9 units long, so x is 9, that means this one's 9. If that's 9, then this is 9 square roots 2. Simple and done. That's all you have to do. All right, here I'm going to compare. Well, if this is 7 square roots of 2, that's x square roots of 2. This is x. This is x. Well, look at this. In this case, what would x have to be? It would have to be 7. And you're done there. Now, sometimes it's not that easy. So here I have 9. This is x square root 2. This is x. This is x. Okay, comparing it to my 45-45, 90. So let's work this one out. If 9 equals x square root 2, then I have to figure out what x is, right? Well, how do I get rid of a radical? I can do two things. I can divide it by radical 2, or I can multiply it by another square root of 2. And so let's do it that way. If I multiply both sides of this equation by the square root of 2, this just becomes 2. So now I have 9 square root of 2 equals 2. Square root of 2 times square root of 2 is just 2x. But I still don't have x by itself, so I'm going to need to divide both sides by 2. That one cancels, and now this is my answer. So what I'm going to notice is that every time I do this, look at 9 was this number right there, that when I have to kind of work backwards, then it's going to be this number 9, and I'm always going to multiply it by the square root of 2 and divide by 2. That's what's going to happen every time. 9 square root of 2 divide by 2. So that one's a little bit funky, but it is still pretty doable. All right, let's look at a 30-60, 90 and those relationships. So again, we have the short side is always going to be across from our 30-degree angle. Our long side is always across from our 60-degree angle, and then the hypotenuse is always there. So the hypotenuse is always twice the short side, and then the tall side is always the short side times square root of 3. So your goal is to kind of figure out what x is when you do these problems. All right, here, this one's pretty straightforward. They gave us the 2, that relates to the x. So that means the hypotenuse would be twice x, which is 4. And this is going to be the small side times square root of 3. And now you have the sides without having to really calculate anything. All right, what about if the hypotenuse is 18? Well, if the hypotenuse is 18, that's 2x, so what would 1x be? We'll just divide that in half, so that would be 9. And if that's 9, then this is 9 square root 3. All right. Here, again, the hypotenuse is 6, so that equals 2 x's. So that means the short side is going to be 1x, so that's 3. And that means the long side is going to be 3 square root 3. Now, the hardest type here is when they give you the long side that is something other than a radical 3, basically. So I'm going to have to say 10 is equal to x radical 3. Just like with the other kind of triangle, the 45, 45, 90, to simplify this, I would have to say, well, I'm going to multiply both sides by square root 3. These two become 3. So now I've got 10 square root 3 equals 3x. But now I need to get rid of that. So x equals 10 square root of 3 over 3. And once again, I'll notice this number, when I have to work backwards, this is always going to become 10, this number multiplied by square root of 3 and divided by 3. Once I get that, I just multiply by 2 to get the long side, the hypotenuse, sorry. And so that would be 10 square root 3 over 3. So this one, and that one. So that's the hardest type. But we're just going to remember that I take this, multiply by square root of 3, divide by 3, and you've got your answer. All right, so that is special right triangles. You're going to use it whenever you have a right triangle that has 45, 45, 90 or 30, 60, 90. And it's just something you want to memorize, the two different, the way those sides work. Okay, talk to you later. Bye.